So today we are doing the second part of chapter 3. So this is 3.2. It's all about theorems with perpendicular lines. So locate this part in your notes. And we'll jump right in. So here is the first theorem. The way they number these is what chapter is it in and which theorem is it. So this is the first theorem in chapter 3. So theorem 3.1. This isn't like universally known as theorem 3.1. You're not going to go to college and be like, well, back when I learned theorem 3.1, this is just what it's called in our book, okay? But this theorem says that all right angles are congruent. So, the way you would write that using symbols is if the measure of angle A is 90 degrees and the measure of angle B is 90 degrees, then angle A is congruent to angle B. Here's what that would look like in picture form. This theorem says that if two lines are perpendicular, they intersect to form four, underline the word four right angles. So usually only one of them is labeled, but you know that all of the angles at that intersection are right angles, okay? So in symbols, this says that if line N is perpendicular to line M, then the measure of the first angle is 90, the second angle is 90, the third angle is 90, the fourth angle is 90, and it looks like that. So all of the angles, like I said, typically one of them is labeled. You would know that they're all 90. Questions? This one states that if two lines intersect to form adjacent congruent angles, then the lines are perpendicular. So basically, if you have two angles that are formed by two intersecting lines, so see straight line here, and I have two angles that are right next to each other. If those angles are congruent, that means that they form a straight angle, so they add to 180, and they're the same. Well, what's the only way you can add to 180 and be the same? 90 and 90. So that's why we're saying that these lines would have to be perpendicular if those angles are congruent, because they'd have to both be 90 because they're a linear pair, essentially. Any questions? It's a lot, but it makes sense. Just think back to what you know about linear pairs. They have to add to 180. Think about what you know about congruent angles. They have to be the same. 180 divided by 2, you get a 90 and a 90. So if two sides of adjacent acute angles are perpendicular, then the angles are complementary. So basically, if you have two angles, they're acute, so they're both less than 90, and their sides are perpendicular. So if I tell you that EF and EH are perpendicular to one another, and you can see two smaller angles inside of there, they're going to be complementary. They're going to add to 90. Okay? So we can jump right into some examples. You should have this all in your notes already, so we can just get going right through it. This says in the diagram, line G is perpendicular to line E. So where's E? I think that's a typo. Should that say L? Mine says L. Does yours say E?
No, it says L.
Okay, so see G. I think this should say L. Make that an L. So line G is perpendicular. We're just going to say line L. It's also perpendicular to line F. All right? Determine whether enough information is given to conclude that the statement is true. So the first one asks, is angle 6 congruent to angle 10?
Yeah.
Why?
Because they both got the boxes. Is they the same size?
Yeah.
The same
Whoops. Yes. So the reason would be that they both have the boxes. What does the box mean? 90 degrees. Now, a few extra boxes popped up. Did you see how this one is now marked 90? This one is now marked 90. I usually do that actually for all 4 angles. So if this is perpendicular, we got a 90, a 90, and a 90, right? Down by angle 10, we have 4 90-degree angles. Now, these extra ones didn't pop up on these slides because these aren't really important. The important ones are the numbered angles, so you can focus on those. But angle 7 and angle 10, are those two congruent? Yeah, same reason. They're both right angles. If you can show that they're both right angles, they're going to be congruent. What about angle 6 and angle 8? Are those congruent? No. Why not?
Because one is like obtuse, another one is right.
So this one's a right. I can't really make any conclusions about this angle because there's no information given. You can't just ever assume the measure of an angle. It needs to be labeled for you. So if there's no box, even if it looks like it's a 90-degree angle, if it's not at a place where perpendicular lines meet, you cannot conclude that it's a right angle. All right, so that one's a no. What about 7 and 11?
Yes.
That's a yes. They are both right angles again.
What?
All right, 7 and 9. Are those congruent? No. Again, we don't know anything about the measure of angle 9, so you can't. Hey. Shh. Quit talking. And then 6 and 11. Yeah, those are both right angles again. So only 2 that are both proven to be right angles are congruent. Let's go to the next one. Number 2. 2a says given that line P is perpendicular to line Q, write an equation to find the value of x. So what do I know about these 2 angles if the sides of those angles are perpendicular? Yeah, they're going to add up to equal 90. Whoop. Sorry, I thought the answer popped up. I guess it doesn't say find the value of x. It just says write an equation. So we're done. Yeah, you can solve it pretty quickly if you wanted. All right, here's 2b. Okay, so given that line P is perpendicular to line Q, write an equation to find the value of x. So if the lines are perpendicular, what do we know about each of the angles? They're 90. So you can set that equal to 90. Now, even if they hadn't told us in the directions that they were perpendicular, we could still conclude that they're perpendicular because they're congruent.
I'm just going to dump it and hide it over here.
So we know in the diagram below that it looks like ray EF, so this guy right here, and ray EH are perpendicular. The measure of angle GEH is 30 degrees. We want to find the value of y. So what do I know about these 2 angles when I put them together? They should equal 90. If these lines are perpendicular, the sum of the acute angles that are formed should equal 90. So I can write this equation. 6y, that's this angle, plus the 30, that's this angle, equals 90, which is the whole thing. It was in the directions. GEH 30. All right, now what? Minus 30 from both sides.
Divide by 6.
Mm-hmm. Very good. So this time we're given that they're perpendicular, right? Ray AB is perpendicular to ray AD. And that angle BAC, so BAC is congruent to angle CAD. Find the value of the variable. Any ideas? Z plus Z, good. Z plus Z equals what? 90. What is Z plus Z?
2Z.
2Z. So 90 divided by 2Z equals 45 degrees. Perfect. Questions? So it says find the value of the variable. I am given that angle EFG is congruent to angle HFG. So they are a linear pair, right? I can tell because they form the straight line when I put them together. Or the straight angle, if you want to call it that. So all together they equal 180, right? Both of these. And they're congruent. So what do they each equal?
90.
90. So I can just set this angle equal to 90. It's written a little differently in Theorem 3.3, but I think it's easier just to kind of reason your way through it each time. If they add to 180, if they're congruent, they're 90 and 90. The theorem says, though, that if they're congruent, formed by two intersecting lines, that they're perpendicular, and therefore 90. Either way, you end up with that they're 90. All right. What is 90 divided by 5? 18 indeed. Questions? All right, this one has a star by it, which makes me a little nervous. Given that ray AB is perpendicular to ray AD, find the value of the variable. So what should I do? 36 plus 9y equals 90. Now, addition is commutative, which means the order doesn't matter. So mine says 9y. If you put the 36 in the front, you'll get the same thing. Either way, we subtract 36 from both sides. What's y equal? 6. What are your questions on today's lesson? So we have one more lesson to do this week. That's 3.3 tomorrow. Thursday we're going to review. Friday we're going to have a quiz. And you will be free for the weekend. Any questions?